Hello and welcome back. In this video, we'll talk about Google Colab and Jupyter Notebooks. Google Colab is the platform that we will be using to write our code, and Google Colab makes use of Jupyter Notebooks as the interactive development environment to write Python programs. An advantage of Google Colab is that you don't need to download any software or install Python on your machine. So you can do it all on the cloud. And Jupyter offers an advantage in that it allows you to integrate HTML and LaTeX alongside Jupyter to create interactive notebooks. So in this video, we'll take an overview of how these two technologies, namely Google Colab and Jupyter Notebook, work and how they help us write code using Python. So what is Google Collaboratory? Google Collaboratory is a service that requires no setup to use and provides free access to computing resources, including some advanced computing tools such as GPUs and TPUs. Google Colab is well suited for machine learning, data science, and education, and it is that last piece of education that we are going to be making use of Google Colab. So Google Colab is what we call as a software as a service or a SaaS cloud platform that is part of Google. Colab allows you to write and execute Python code. You don't need to do any configuration, so it is a cross-platform solution in that you could be running this off of Mac, Windows, or Linux. It creates a web link that you can use to share your code, and it also provides you with CPU, central processing units, and graphical processing units for more advanced computing for free and allows you to scale up as your needs increase. For what you're going to be doing in this class, all you need is a free Google account to get started. It is a Gmail account that allows you to access Collaboratory. So Google Colab uses Jupyter Notebooks to run Python. Jupyter Notebooks or Jupyter ecosystem or environment is a separate ecosystem, and you can learn more about it by going to jupyter.org. And Jupyter allows you to not just run Python, but run 40 different types of computer programming languages, R, C++, so on and so forth. But in Google Colab, all you can do is you can only run Python using Jupyter. So what is the advantage of using Jupyter over some of the other interactive development environments that are available to run Python, such as VS Code or Spider and others? One, Jupyter adds a lot of interactivity to your coding. So in addition to allowing you to write Python, you can also mix it with Markdown, HTML, and LaTeX to create interactive notebooks. You can include data, text, figures, videos alongside your code. So your notebook is not just a programming script, but rather a notebook that has all the information that you need alongside with the code that you want to execute. When you use Jupyter Lab through Google Colab, you don't need to set up anything. And not only that, when you develop a notebook there, it automatically gets saved on your Google Drive, and then you can also upload it to repositories such as GitHub. So keep in mind that yes, Jupyter Notebook IDE can be installed on your computer, and that has some advantages. But the biggest advantage you get for this course is that since Colab implements it on the cloud, everything is hassle-free. You don't have to worry about installation and maintenance issues. So if you go to Google Colab and open a notebook or a new notebook, what you're going to get is a screen that looks like this. And what it is it's got IPYNB. It opens a file with IPYNB extension. IPYNB stands for Interactive Python Notebook. That's IPYNB. And Google sequentially numbers it untitled 0, 1, 2, 3, so on and so forth. You can click on this and change the name to something that's more intuitive to you. And what Google contains, contains code blocks. So there is a code block. You can click on this plus sign with code to get the code block, and then you can click on this plus to get the text box. So you can mix and match code blocks where you run Python code or write your Python code, and with text boxes where you're going to put in text, images, videos, anything that HTML allows, as well as if you want to put fancy mathematical equations, you can make use of LaTeX, which is available to you there as well. So which also means if you want to run Jupyter notebooks and create Jupyter notebooks, interactive Jupyter notebooks, clearly you can just write Python code and keep it. But to get the true benefit, you need to know a little bit of HTML and LaTeX. HTML stands for Hypertext Markup Language. This is the language that's used and recognized by web browsers. So web browsers can parse this language and render what's written in it. Everything in HTML is written using tags. Tags are essentially these angular brackets, and there is some tag that is included within these angular brackets. And then there is this slash whatever that you want, the heading or any other format that you want here that is included in the angular bracket. So anything between the angular bracket and slash angular bracket is rendered based on what you put for your code here. For example, if I were to put h2 and slash h2 in angular brackets, anything I put in between them becomes heading 2. Okay. So text can be normally typed within Jupyter Notebook. So typically what you need are texts, which you can type normally, as well as some headings to kind of separate things out. You may also want to change the color of the font to add some color to your notebooks, but that is by and large what you will be using to in as far as Jupyter, as far as HTML is concerned, for most of your notebook development needs. If you want anything more than that, refer to the Jupyter, HTML cheat sheet. There are many such cheat sheets that are available on the web, and you can also ask generative AI tools to give you the HTML tags to do certain things, and it will show you those tags because there is a lot of support available on the web for HTML as well. If you want to put in mathematical formulas, you can put them using LaTeX. LaTeX is a typesetting software that shines when it comes to working with mathematical formulas. There is a technology called MathJax, and what MathJax does is MathJax takes your LaTeX code and turns it into nice looking mathematical symbols in the Jupyter notebook. Okay, for example, if I were to put slash int between either $2 signs or between $sign and $sign, or between $2 signs and another $2 signs, you will get an integral, a symbol of integral followed by whatever. So again, you will not be using a lot of math in this course, but nonetheless, learning LaTeX, learning some symbols comes in very handy, particularly to put fractions as well as derivatives, integrals, and such. It is also useful to put Greek letters. So there is a cheat sheet that's available for LaTeX. And again, you can ask generative AI and say, how do I put, say, alpha in LaTeX, and it'll show you the formula. Keep in mind that you go to a text box and put dollar for inline rendition of that formula, or if you want it on a separate line and centered, then you use the $signs. And anything that's between $signs is interpreted to be LaTeX in Jupyter. So again, keep in mind that HTML and LaTeX syntax is vast, but we are not going to be using all of that. Even just a few commands here and there, such as using, for example, the frac, which is used for fractions, integrals, differentials, can make things look very professional and add a lot of interest in your notebooks. Similarly with HTML, even adding a few headings here and there or adding some color to your font would catch attention and make your books all the more interactive and interesting. So I encourage you to learn HTML and LaTeX, but again, we don't need a lot of that, just a few things here and there that will help us make our notebooks shine, not just with Python, but other things, but with the information associated with it as well. So one other good thing about Colab is Colab automatically stores the notebook on your Google Drive. So you can see that there is a default name that is given as untitled, a number, and then .ipynb. You can simply click on it and change that untitled 0 to whatever intuitive name that you want. If you want to add a code block, you just click on this plus sign and it'll add the code block. A code block is always denoted by this arrow sign here or the play button, which allows you to execute whatever code you put in that box. Similarly, you can put a text box and then the text box will render the markup and allow you to work with markup or HTML that you need. Okay. So in summary, Google Colab is a software as a service platform to run Python. It makes use of Jupyter Notebook technology to execute Python code or write your Python code. One advantage of Jupyter Notebook is you not just write Python, but you can intersperse it with text boxes using HTML, Markdown, and LaTeX. Which kind of adds interactivity to your notebooks or to your scripts. Okay? Jupyter Notebooks are run on a browser, so you don't need to download any special software to run Python. So that's one of the big advantages of running things on a Jupyter Notebook. And then you can add HTML, which is the language of the web, and LaTeX, which is used for putting mathematical formulas, using dollar tags for LaTeX, and using the angle tags for HTML. Again, the ecosystem for HTML and LaTeX are vast. There's a lot of syntax, a lot of things you can do, but all we need is a few things like how to put headers, how to change colors, how to write equations, and you can get a long way in making some dazzling notebooks alongside your Python code. So I will see you in the next video with a more hands-on demonstration of Google Colab. Until then, take care and stay safe. Goodbye.